All right, guys, let's talk thermometers and the different types. Okay, so the best way to take temperatures of food naturally is by using a food thermometer. Okay, and there are different types. The first one that the PowerPoint mentions is the bimetallic stemmed thermometer, which looks just like this. It's got a red covering on it. Normally, if we were in class, I would pass it around and let y'all take a look at it. Hopefully, we'll be back in class one day soon and y'all can take a look at it in person. But you can see it's got the metal point at the end, and it's got some numbers, if you can see them at the top. Okay, so what you would do is that you would stick this into the food, specifically thick food. You can imagine if you had like a fish fillet or a hamburger patty or something like that. It's really thin, and this would go right through it. Okay, so bimetallic stem thermometers are to use to check the internal temperature of food, specifically thick food. Like if you had a big roast, maybe even a steak, a Boston butt, which is where you get pulled pork from and stuff like that. Those are real thick pieces of meat, so you can stick that in there and it won't go all the way through. It has on it, and you cannot see it. There's no way you're going to be able to see it. I can feel it on here. But make sure you look at your PowerPoint, and when I post a picture up, I'm going to post pictures of all the thermometers up as well with descriptions of them. Take a look at it. The bimetallic stem thermometer has a dimple on it. They call it a dimple, okay, but it is a little indentation on it, okay? And I've saw this on my certification test, and I've seen it on several practice tests. It'll say, how far do you have to enter the bimetallic stem thermometer in a piece of food to get an accurate temperature? You have to stick this in the food, so say it was a roast, you'd have to stick it in the roast all the way up until the dimple. Not before the dimple, not past the dimple, but right up until the dimple. Okay, so this is for, again, bimetallic stem thermometer for specifically thick food. Okay, you need to know where the dimple's at, and you need to insert it into the food up until the dimple. Okay, it does have a calibration nut and things like that, and we'll talk about calibration in a little bit, but this is your bimetallic stem thermometer. Okay, so you've got that. You have your, the notes call it thermocouples or thermistors. Okay, so thermocouples or thermistors is going to be this type of thermometer. Basically, it's a fancy way of saying that it's a digital thermometer. Okay, and you've probably seen these before. This one's my husband's I stole from the house. I need to bring it back. But anyway, it was lighting up blue. I'm not sure why it's not lighting up now. There it is. Okay, so this is a digital thermometer. If you see it, it gives your readings out digitally. Okay, whereas that one is more manual if you look at it again. Okay, not digital. All right, it's more manual. All right, whereas this is digital. So they call these thermocouples or thermistors. Basically, it's a fancy way of saying a digital thermometer. Okay, that's all it is. This you can use with thin food or thick food, either one. Okay, it'll work for either one, fine. Okay, there's different type of probes. So the thermocouples or thermistors, or also called digital thermometers, have different types of probes. The book goes over those. I don't have any of those specifically to show you, but the book goes over the different ones. There's something called an immersion probe. An immersion probe is what you're going to use for soups and liquids. You may see that question. You may see something that says, I'm trying to check the temperature of a large stock pot of soup, or a large thing of chili, a large thing of, they like to mention clam chowder. I don't eat clam chowder. But anyway, I've seen several practice tests say you're trying to check the receiving temperature of clam chowder. What kind of probe are you going to use? You're going to use an immersion probe, which makes sense because you're going to immerse it in the liquid. Immersion probe, okay? So these things come with different types of probes. An air probe is going to be for coolers, coolers, ovens, and that sort of thing is an air probe. Okay, so you can also, they make thermometers where you can pull this off and stick like an air probe on it. You would use an air probe again for like the temperature of a cooler, the temperature of an oven, or something like that. Makes sense. Air probe, you're checking the temperature of the air, right? So that makes sense. They also call this sometimes, like this particular one would be like a penetration probe. You're penetrating the meat and sticking it in there, so you may see penetration probe, okay? Or those are the different types of probes that you can put on a digital thermometer, okay? Just gonna check the PowerPoint real quick, make sure that I didn't miss any. The immersion probe, again, soups, sauces, oil, any kind of liquid, immersion probe, because you're gonna immerse it in the liquid, okay? You got the penetration probe, which is like this one, like we said, for thick meats and things like that. You got the air probe for temperatures of air, like in your cooler and your oven. You also have a surface probe, which you could put on here. A surface probe would be surface, ideally if you're checking the surface temperature of something, like maybe a griddle. Maybe you want to see how hot your grill is or how hot your griddle is. You could put a surface probe on there and get a temp on that as well, okay? The other type of thermometer that we have is the laser thermometer. Never, ever, 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 ever use the laser thermometer. Sometimes they call it an infrared thermometer to check the internal temperature of food. You will never use a laser thermometer or an infrared thermometer to check the internal temperature of food. Why? If you shoot it out, let me see if it'll show. You can't see it, but on the wall here is a tiny, tiny red dot, like a laser pointer, okay? It doesn't laser, so it'll tell you the temperature, and then it flashes it on here. Is that going inside the food? No, so it's not gonna give you an accurate temperature. So you cannot use these to check the internal temperature of food. So, what would you use them for, you might ask? You can check the surface temperature of stuff. So again, if you have a hot griddle, maybe you're working at Waffle House and you're making a bunch of waffles, right? And you got your big griddle in front of you and you want to see how hot it is, the surface of it, you could use a surface probe like we said, or you could use an infrared or laser thermometer and get the temperature of it, okay? So that's what you would use these for. They like to say that you never use these for food because they like to ask that question. They'll try to mess you up and say, you know, you can use an infrared or laser thermometer to check the internal temp of food. No, you can't because it's not actually going in the food, okay? They like to talk about clam chowder a lot. I don't know why they like to talk about clam chowder, but they mention that a lot on different practice tests. The question was, you'll see something saying, you're receiving a shipment of clam chowder. You know, maybe you work at Salvo's or somewhere, and, you know, for example, and you're getting a big old shipment in of clam chowder, you need to make sure it's at a good temperature to be able to receive it. What would you use for that? You would use an immersion probe, because you're going to immerse, you're going to open up, you're going to take a bowl or, you know, whatever that's in a container of the clam chowder, open the clam chowder up, stick the immersion probe thermometer in there, get your reading on it, okay, and we're going to learn about this later on, but it's got to be at 41 or below. Remember our danger zone, 41 to 135? If it's cold food, clam chowder is supposed to be cold at the moment, right? You're getting it delivered. It's got to be at 41 or below, then it's okay to keep that food. If the clam chowder was at above 41, you got to tell the delivery person, no, I'm not taking that, it's not safe, okay? But they like to mention that question a lot, like if you're going to check the temperature of like clam chowder or soup or something, it's an immersion probe. You're going to open it up, stick the thermometer in there, and take your temp. They ask you periodically about the surface temperature of something. If it's the surface of something, then yes, the infrared or laser thermometer. If it's like a fish fillet or something like that, that's real thin, so you would probably use your thermocouple or your thermistor or your digital thermometer. If it's really, really thick, you could use your, I'm gonna drop it. If it's really, really thick, you could use your bimetallic stem thermometer. You do need to know how to calibrate these. Calibrate them, they either use the ice point method or they use the boiling point method. Ice point method is 32 or below. You would get a big old pot, fill it with some ice water, and when it reaches the temperature of 30, plus or minus, it can be plus or minus 2, but when it gets close to 32, plus or minus 2, then that's the ice point method. You stick it in there and then it's calibrated. You could do the same thing, but do the boiling point method is when you take a big old pot of boiling water, when it reaches 212, then you know that your thermometer is calibrated. They will ask you for your thermometers, like when you calibrate them, the two different methods. Again, ice point method, 32 degrees, boiling point method, 212. They will ask you how close it has to be to the 32 or the 212, depending on what one you're using. It's plus or minus 2, okay? It can only be off by 2, plus or minus 2. They also ask you sometimes for air probe, like your air probe, if you're trying to calibrate a thermometer using the air probe. As far as the air can be plus or minus 4, okay? So don't forget that. Again, if you're using a regular thermometer using the ice point or boiling point method, plus or minus 2. If you're trying to calibrate your air probe, it's got to be calibrated to plus or minus 4. Okay, so don't forget either one of those. Okay, so hopefully that helps you out as far as the different types of thermometers. I'll do another video where we go over them, and I'll also put pictures up on Google Classroom to kind of help you out. So make sure you take a look at those. Thermometers can be kind of confusing, you know, if you're not paying attention and reading over this stuff, okay? As always, if you have any questions, you know where to find me. I hope to see you guys really soon, hopefully in a couple of weeks. Yay! Have a great rest of your Wednesday. Bye.